Sega Sonic fan here, just talking about how to install a cooling fan for your Avid Digidesign Control 24 mixer. This is a giant mixer. It's about $4,000. Everyone has one in their living room, of course, and anyone can do this hack. No, just kidding. You should know what you're doing if you're doing this. And these power supplies, this is the power supply right here. These are really hard to come by. I actually don't know a source to replace these. So I'm going to actually give this one a little extra TLC. I've already recapped it with entirely new Nichicon capacitors. And what I've noticed is these 4 heat sinks right here get super, super hot, even when there's no load applied, even when it's sitting idle in the offline mode for a few hours. So I'm going to install a little cooling fan right there to chill it out. It's pretty straightforward. A couple things you need to know when you're installing a cooling fan, especially with audio gear. You need to isolate it with 2 diodes. So you want, there's red, black, and white, as you can see here, the 3 pins. This is like a typical computer case fan. The red is your positive voltage, black is your ground, and the white is your PWM control signal. We're not using that, so you can leave that disconnected. With the red one, you want a diode, which is in this heat shrink tubing, so you can't see it now, but there's a diode here. And the cathode side goes towards the red, the anode side goes towards the cable. And then with the black, the ground, you do an opposite. Anode side towards the black wire, cathode side towards the cable. What that does is that lets current for the positive rail flow in that direction, and it makes sure that current for the negative rail also flows in that direction, and nothing flows back towards the power supply. Why are we doing this? Because this fan will generate noise, or also known as voltage ripple, across the power rails. And we don't want that to be added to the Control 24. This plug right here carries the voltages we'll be using, and it goes to this giant analog board. You want this to be as isolated as possible, and so 2 diodes are a really good way to do that. Now this is a 12-volt fan. It's rated at 0.08 amps, which is pretty standard amount of power. There's no 12 volts available on the Control 24 power supply. However, there is a plus 10 volts, which is fine because we want to run this really, really quiet, so when somebody's in a recording session, they don't hear a fan going and think it's part of the music. So what we'll do is, what I've already done here is added 2 parallel 100 ohm resistors that make a 50 ohm resistor now because they're in parallel, and also have a higher wattage capacity because they're in parallel. So there's 2 50 ohm resistors, 2 diodes, each with a 0.7 volt drop, and a fuse in here just for protection. So that means you're going to get less than 9 volts, and then the diode drop is going to drop it even more. So you'll get a much lower voltage, which I measured, using a potentiometer to find just the right amount of noise. You just put a little potentiometer in series or rheostat, either one, same deal, and you just turn it and see, limit the power until you find a good sweet spot that works for you. So if you look over here on the edge of the connector, it's actually labeled here, ground. I think the extra one is unused, and then there's a minus 10 volts, a plus 10 volts, and a minus 10 volts. So I'll be soldering these 2 wires there, and then using, some zip ties or hot glue or Velcro or something, we'll find a way to retain this here to blow the wind, down into these 4 really hot heat sinks. And then the air will escape through the vents along the top. And that's all there is to it. So happy hacking out there, and like I said, don't do this if you don't know what you're doing and have a lot of experience under your belt, because these are not cheap. And yeah, this is Sega Sonic Fan, signing out.